The water here is only 40 meters deep, but it sits more than 100 miles from shore. That single fact, shallow enough for steel foundations, far enough to escape every planning objection, is what turned a sandbank in the North Sea into the footprint of the largest offshore wind installation ever attempted. The number that stops people is 8.1 gigawatts. That is the total generating capacity being installed across the Dogger Bank zone as of 2024. To put that in context, a single large nuclear reactor produces roughly 1 gigawatt. Dogger Bank, when fully built out, is designed to exceed 8 of them, all of it powered by moving air above a cold grey sea. But here is the contradiction the title is pointing at. Wind farms are supposed to be the smaller, distributed answer to energy. Dozens of turbines spread across a hillside or a modest cluster at the edge of a bay. What happened at Dogger Bank is something categorically different. It is a single coordinated energy zone the size of a small country, planned across multiple phases, built by competing consortia, and wired to shore through cables that run more than 100 kilometers under the seabed. Calling it a power plant is not a metaphor. It is an engineering description. The Dogger Bank itself is a vast submerged sandbank sitting between Britain and the European continent. For centuries, it was known primarily as one of the richest fishing grounds in the world. The water is genuinely shallow by North Sea standards, rarely exceeding 50 meters across most of the bank, which matters enormously for engineering. Fixed foundation wind turbines, the kind anchored directly to the seabed with steel monopiles, become economically unworkable beyond roughly 40 to 50 meters of depth. Deeper than that, and you enter the domain of floating turbines, which are still far more expensive to build and have not yet been deployed at scale. Dogger Bank sits right inside the viable window. The Crown Estate, which manages the seabed around England, Wales, and Northern Ireland, opened its third licensing round for offshore wind in the late 2000s. Dogger Bank was the largest single zone in that round. In November 2008, a consortium called Forewind was formed by 4 companies, SSE, RWE, Statoil, and Statkraft, specifically to pursue it. By January 2010, Forewind had been named the developer for the zone. The ambition at that stage was extraordinary. Original projections put the potential output as high as 9 gigawatts. That number did not survive contact with reality. By 2014, the projected capacity had been scaled back to 7.2 gigawatts. A year later, it was cut again to 4.8 gigawatts. The reasons illustrate exactly how megaprojects of this scale run into constraints that are invisible on a planning map. Grid connection infrastructure on the British mainland was not sized to absorb power at that magnitude from a single remote location. The economics of financing, interconnection, and contract pricing had to be renegotiated multiple times before construction could realistically begin. What looked like a simple resource, reliable wind over a shallow bank, turned out to require an entirely new chain of supporting infrastructure before any electricity could reach a single home. Ownership structures shifted as the project matured. Statoil, later renamed Equinor, absorbed Statkraft's share. RWE's subsidiary Inagi separated out one section, renamed it Sofia Offshore Wind Farm, and pursued it under independent development. By 2020, Eni had taken a 20% stake in 2 of the phases. What began as a 4-company consortium had evolved into a multi-party industrial program with separate financing arrangements, separate grid connection strategies, and separate contract timelines. The turning point that made construction viable, not just financially but technically, was the Contract for Difference auction in 2019. All 4 farms within the broader Dogger Bank zone, including Sophia, secured contracts through that process, guaranteeing a strike price for the electricity they would generate. With revenue certainty in place, the billions of pounds required for offshore construction could be committed. Delivery dates were set between 2023 and 2025. Then came the machines themselves. Dogger Bank A and B were designed around 190 GE Haliade-X turbines, 95 per site. These are not conventional turbines scaled up slightly. The Haliade-X was, at the time of selection, the most powerful offshore wind turbine in commercial deployment. When upgraded versions rated at 13 megawatts became available, the project adopted them. Each individual turbine at that rating can power roughly 16,000 homes, 95 of them on a single site, separated by enough distance to avoid aerodynamic interference, can collectively generate 1.235 gigawatts, more than many conventional power stations. Getting that power to shore required solving a separate problem entirely. At distances beyond roughly 80 kilometers, transmitting electricity through conventional alternating current cables becomes inefficient because the cables themselves consume a significant fraction of the power they carry. The solution chosen for Dogger Bank A and B was high-voltage direct current transmission, HVDC. ABB was selected to provide the HVDC cable system. Direct current does not suffer the same resistive losses over long cable runs, which makes it the only practical choice for connecting a wind farm sitting 130 kilometers offshore to a substation on the Yorkshire coast. The substation on land is at Creyke Beck, near Cottingham in the East Riding of Yorkshire. The turbines convert wind to AC electricity. The offshore platform converts it to high-voltage DC. The cable carries it under the North Sea and beneath the sea floor. And a converter station at Creyke Beck turns it back into AC before it enters the national grid. Every step in that chain had to be engineered, permitted, financed, and built. The turbines are the visible part. The invisible infrastructure is equally complex. Pre-assembly of the turbines happened at Abel Seaton Port in Hartlepool, a logistics decision that created around 120 skilled jobs at the port during construction. Turbine installation at Dogger Bank A began in August 2023. On the 10th of October 2023, Dogger Bank Wind Farm produced electricity for the first time. That date marks the moment the project crossed from construction program to operating power plant. The financial scale is difficult to absorb. At the COP28 summit on the 1st of December 2023, energy firms RWE and Masdar committed to funding Dogger Bank projects through an £11 billion investment. That figure does not cover the full build. It represents one tranche of capital in a program whose total cost across all phases runs considerably higher. Infrastructure at this scale is not funded through a single transaction. It is assembled from layers of equity, debt, government contract guarantees, and long-term power purchase agreements, each layer dependent on the stability of the others. There are legitimate uncertainties still surrounding the project. The original capacity projections were revised downward twice before settling at 3.6 gigawatts for phases A, B, and C, less than half the 9 gigawatts first announced. Whether the full 8.1 gigawatt figure, including Dogger Bank D and the separately developed Sophia farm, will ultimately be realized, and on what timeline, remains a question the project has not yet answered. Offshore construction at this scale is subject to delays from weather, supply chain constraints, and grid readiness that no planning document fully anticipates. What the project has already demonstrated, regardless of those uncertainties, is something more significant than a capacity figure. It has shown that the engineering logic which made individual offshore turbines practical, water shallow enough for fixed foundations, wind reliable enough for financial modeling, distance far enough to avoid onshore objections, can be applied at a scale that was previously associated only with thermal power stations or hydroelectric dams. The Dogger Bank zone is not a collection of wind turbines. It is a power plant that happens to have no fuel cost, no cooling water requirement, and no combustion emissions, built in a location that was chosen precisely because its geology made it possible. The lesson the North Sea is teaching is not that wind power has become convenient. It is that the constraints which defined what a power plant could be, a central location, a concentrated fuel source, a contained footprint, are no longer fixed. The new constraint is grid infrastructure, and the new frontier is not the turbines themselves, but the cables, converters, and substations that allow energy generated 100 miles offshore to arrive reliably in homes on a winter evening. That is the engineering problem the next generation of projects will have to solve at even greater scale, because Dogger Bank, for all its size, is already being described as a template rather than a ceiling. Visual reconstructions are illustrative. Facts and interpretations are based on the sources listed in the description.